Hey, Algebros, let's do some more algebra. What do you say? Been talking about finding x and y intercepts. We've been talking about it all year and definitely lately, but I'm sure you've been wondering, what about when it's in vertex form? Well, it can be a little trickier, but it's basically the same rules as always. Just to recap here, to be an x-intercept, that means the y value is 0, so you plug in y for 0 and solve. To find the y-intercept, to be on the y-axis in other words, your x value has to be 0, so you plug in 0 for x and simplify. Before we begin that though, just a quick detour. This is going to come up. What if you had an equation that said a squared, so some number squared, is equal to 25. Now to solve that, I'm sure a lot of you know that to undo squaring, the opposite is to take the square root. So a would be the square root of 25, and the square root of 25 is 5. But remember, your goal when you solve an equation is to find any and all values that make this equation true. So definitely 5 works. 5 squared is equal to positive 25. But that's not the only solution. What other number, when you square it, gives you positive 25? And hopefully you're thinking to yourself, also negative 5. So really, the two answers to this are positive and negative 5, or a lot of times we'll write simply plus or minus 5. And that just brings up this idea in math, which comes up often and people overlook it all the time. Even kids in my AP Calc class will sometimes miss it. If you take the square root to help you solve an equation, you have to remember that there's two solutions for this, so you have to consider the positive and negative square root of 25. So whenever you take the square root to help you get rid of that squared, just remember to slap a plus or minus out in front of the square root. Positive, negative 5, plus or minus 5. Okay, back to this now here. Just to do one of these problems, which we've been doing already, but it should be quick, but it can't hurt to do one more. If it's in standard form, ax squared plus bx plus c form, let's find these intercepts. The y-intercept is really easy because we plug in 0 for x, and a lot of you have noticed that when you plug in 0 for x here, this part becomes 0, 0. You're always left with c, whatever's on the end, because these parts drop out. So a lot of times people won't even show work. They'll just say, hey, when it's in standard form, that number on the end is the y-intercept. And that's fine, negative 56 or 0, comma, negative 56. To find the x-intercepts, we're going to put 0 in for y, and this is something we've definitely been working on. So putting 0 in for y now means we're solving this equation, right? We're setting this entire equation equal to 0. And to solve this kind of equation, what are we doing? That's right, we're factoring. So when I factor, what is the first kind of factoring I look for? Hopefully right now at home you're saying GCF, greatest common factor. And I can take a 2 out of all of these. So I take out 2, and now on the inside of that quantity there will be x squared minus 12x minus 28. And now I've taken that 2 out, but it's time to factor this trinomial that's left. That's a trinomial. It starts with x squared, so this should be a nice, easy unfoil. X squared goes to x and x, and I'm looking for the two numbers that multiply to be negative 28 and add up to negative 12. You might have to think about it a minute. Feel free to hit pause if you want to try it on your own, but that's going to be negative 14 and positive 2. Negative 14 and positive 2. And once you've factored it, of course, we set each factor equal to 0. This 2 doesn't affect the solution. It doesn't have a variable. And when you set that equal to 0, you get x equals 14 and x equals negative 2. Hopefully that's nothing new, maybe just a little helpful review, a little brush up on that. We could always use a little factoring help. But now to the vertex form problem, which is the recent form we've been working with, which looks like this. Remember, it's when you've got the quantity squared, the parentheses squared, and there's something often on the inside. So we have this. So just for practice, since it's new lately, let's talk about what's the vertex and then find the intercepts. The vertex, remember, the x-coordinate is the x value that makes this inside be 0. So you see plus 7, it's negative 7. The y-coordinate of the vertex is negative 25, and we know we could talk about the axis of symmetry, we could talk about the domain and range, but let's focus on the intercepts right now. The same rules apply though. The y-intercept means you have to plug in 0 for x. Just be careful, because when you do this, you actually have to do a little work after it. Unlike in standard form where it's just the number that's left on the end, because now you've got this. When you plug 0 in for x here, you get 0 plus 7, which is 7, and then you have to square. 7 squared is 49, and then subtract 25. So 49 minus 25 is 24. Okay, there's our y-intercept. It wasn't hard, but it was a little bit more work than standard form. The zeros, or the roots, or the x-intercepts, they're all the same thing essentially. We're going to plug in 0 for y and solve this. So when I set this whole equation equal to 0, I mean, it doesn't matter if you like to write the 0 on the left side or on the right side. When I set this whole equation equal to 0, look what I'm trying to solve here. Now, one way to handle this is you could FOIL this out, meaning change it to standard form, like we've done recently, and then try to factor it, because right now this is not factored form. But that's actually the slightly longer way. If you've got this squared form, watch what I'm going to do. And this would maybe be a little new. This might not occur to a lot of you. I'm going to add 25 to both sides. So I'm going to move that over there. And now we have x plus 7 squared is equal to 25. And that's a lot like our problem which we did at the beginning, which looked like this. A squared equals 25. Well, I've got this squared equals 25. So to get to x, I want to subtract 7, but I can't do it yet because it's on the inside of these parentheses. So I've got to get rid of that exponent. So I'm going to take the square root of both sides. That's how you get rid of it. Squaring takes away the square root takes away the squared, and now I'm left with just x plus 7 is equal to, but over here you have to remember plus or minus, like we talked about in that little warm-up. When you take the square root, you've got to remember to put plus or minus in front of there, because there's two solutions. So you get plus or minus the square root of 25, or plus or minus 5. And now you're going to solve for x. It might seem a little weird here, but be careful. This is really like two separate equations. And until you're really good with working with these, you might actually like to write it. That means x plus 7 is equal to plus 5, positive 5, or x plus 7 is equal to negative 5. And solve each of these little equations individually, and you see you get x equals negative 2 from that first, or x equals negative 5 minus 7 is negative 12. So that was a little weird, because you've never done something like that before. But definitely check it out and see why it works. If you take these values and plug them into the original for x, you should get 0. Negative 2 plus 7 is 5. 5 squared is 25, and 25 minus 25 is 0. When you plug negative 12 in, negative 12 plus 7 is negative 5. Notice what it made. It was negative 5, and negative 5 squared is still positive 25, so you'll get 0 at the end. If you want, I'm going to do just a couple more examples, just if that seemed a little weird to you, and just so you hopefully feel a little more comfortable. If you feel good, then that's really all I've done here. But another vertex form. What's the vertex? Hopefully you're saying to yourself right now, that's easy, man. That's going to be at positive 1, negative 64, right? Opposite of the inside, whatever's on the end. Y-intercept, no sweat, old man. I'm just going to plug in 0 for x. Okay, so 0 goes in for x, and then simplify. 0 minus 1 is negative 1. Negative 1 squared is positive 1. Just be careful of that. 1 minus 64 is negative 63. And our x-intercepts. X-intercept, we're going to set the entire equation equal to 0. So putting 0 in for y, basically, and now we're going to solve for x. So here we have that situation again, this quantity squared. I'm going to add 64 to both sides. So now I'll have x minus 1 squared equals 64. And now I want to get rid of that squared, so I'm going to take the square root of both sides. When I take the square root, it takes away the squared. They undo each other, what we call inverse operations in math. And now over here, you've got to remember plus or minus the square root of 64, and that's plus or minus 8. So again, you get this plus or minus situation, which is really two different equations. It means x minus 1 either equals 8, or x minus 1 is equal to negative 8, kind of like when we solved absolute value equations. So this one, it's very easy to solve. You get either x equals 9, or this one, when you add 1, you get x equals negative 7. Negative 7, positive 9. And one way to check yourself that would be great is if you wanted to look at Desmos, but you could even think, does this answer make sense? This is a parabola with a vertex at 1, negative 64, so it would be way down if you wanted to see it on Desmos. I know that it's opening up because the lead coefficient is positive, so it would be like this. And so it's going to hit the y-axis, and that y-intercept right there is going to be pretty close to this point because we were only at x equals 1. So that y-intercept of negative 63 totally seems reasonable. And this value is some x value to the right of 1, which is 9. That's the first one we found. And the other one here, which is to the left, is negative 7. And if you notice, there's that symmetry because 9 is 8 units away from 1, and negative 7 is 8 units away from 1, just on either side. So there's always that symmetry, remember, with the graphs. And you could see that on Desmos if you wanted, but you could even sketch a decent approximation of your own to see that it all kind of balances and makes sense. And one more here, just to go out on. This right here, this technically qualifies as vertex form, but it also qualifies as standard form because I don't see the parentheses. But it does qualify as vertex form because there's no bx from standard form. So whenever you have this just x squared plus or minus some constant, you should remember that, hey, nothing's been added to the inside, so the x coordinate is 0, but it has been shifted down 25 units. So it's just been translated downward to 0, negative 25. That 16, you should know what that does. That makes a vertical stretch because it's bigger than 1. If you want to check the graph and see it, it would probably be a very skinny parabola because 16 is a pretty big number compared to the 1 that's normally out there. The y-intercept really shouldn't be any surprise. It's the vertex, but if you didn't notice it, you plug in 0 for x and oh man, that drops out and I'm left with negative 25. Yeah, all we did was slide it straight down, so no surprise there. The x-intercepts, 16x squared minus 25 equals 0. Just good to see this problem as two ways, really. Because it kind of qualifies as vertex form or standard form, it really means you can solve it either way. You could treat this like standard form and try to factor it. It's equal to 0. Let's try to factor this. There's no greatest common factor I can take out, but it is only two terms, and with a minus, And these are both perfect squares. That's a dots difference of two squares. So you could factor it as the square root of 16x squared is 4x and 4x. 1 plus, 1 minus, doesn't matter the order. And the square root of 25 is 5, so 5 and 5. Set each one equal to 0 and solve. Add 5, divide by 4, you're going to get positive 5/4. Subtract 5 and divide by 4, you get that negative 5/4. And there's where you get that plus or minus 5/4. If you didn't notice that it factored and wanted to treat it like a problem we were just doing, where by taking the square root of both sides, they call that solving it by extracting roots. It kind of sounds like a dental procedure. But if you solve the same equation and you said, okay, all I'm going to do is get x squared by itself, and then I'll take the square root. No problem. I'll add 25 to both sides. And before you try to take the square root, you'd want to isolate that x squared. So you would divide both sides by 16. And so this might freak some people out, you youngins who don't like fractions yet. But 25/16 does not reduce, so we'll leave it like that. And when I take the square root of it, this is why fractions are nice compared to decimals, because you'll notice if I take the square root, x would be plus or minus the square root of this side. What's kind of nice, and maybe you're not aware, when you take the square root of a fraction, you're just taking the square root of the whole thing, the top and the bottom. The square root of 25 is 5. The square root of the bottom, the square root of 16 is 4. So same answer either way. So let me know if you have any questions. There's a few of these problems on the worksheet for tonight, so if you have any issues with it, just let me know. And I hope all is well, of course, and just stay in touch and try to keep up with that work for all your classes. Best wishes, guys. Miss you. Bye.